Welcome to education program online with me, teacher Christine, taking you in mathematics for senior 3 and senior 4. So dear learners, our lesson, our topic remains algebra. Under algebra, we looked at the quadratic expression. And under quadratic expression, I believe you picked something on the methods of how to solve the quadratic equations. And then under still the algebra part 2, we have what we call the binomial expression. So a binomial expression, bi means simply 2. Bi means 2. So this is where we are going to deal with the two quantities of algebraic quantities. And these two quantities, you find that the sum of the terms are raised by a certain power. The sum of the terms are raised by a certain power. But under it, before we go to talk about the binomial expression, there are two main concepts that I need us to understand before we go to what a binomial expression. And one of the concept that I need us to understand or to look at is what we call the permutation. Permutation. So, dear learners, that is one of the concepts that I need us to do to look at, and you can treat this one as concept 1 or concept A. So when you talk of permutation, because when you look at permutation and the other concept, or the second concept, when they come together, they form what we call the binomial expression. So because we cannot rush straight to introduce a binomial expression or how to express or how to state express any algebraical terms in a binomial when we don't know what binomial means and what makes a binomial to be called a binomial expression. So the two concepts or the two terms that come together, that we always say the components, all one of it is a permutation. So we need to understand what do we mean by permutation when somebody talks of permutation. Permutation in this case is referred as what? Any arrangement. So you say permutation is any arrangement that involves any arrangement of elements taken from a set. And the order is not, the order is considered. And the order is considered. The order is considered. The order is considered. The order is considered. So dear learners, that is the definition, especially for those learners who are taking additional mathematics. You will find a concept, this concept, they sometimes ask you define permutation. So when they ask you to define permutation, you simply say is any arrangement of elements taken from a set and the order is considered. What does it mean? I want you to understand this are what we mean by arrangement. In everyday life, we tend, even in our homes or in where you always see whatever activity you do, you always tend to see that you organize your things in that proper order. Sometimes, and we know that in our, when we are trying to arrange things in a proper order, we have to follow the two orders. That is ascending, which begins from the smallest going to the highest, or descending, which begins from the highest coming to the lowest. So this is what we call in everyday life. You can decide to arrange your things, and when you are doing that arrangement, do you take a concept or a concern in your mind that what activity, what does this mean when we try to apply it in everyday life in mathematics? When we are doing that, we are already what we call a permutation in mathematics. So we can arrange our elements that you can decide to take from any set, but make sure that the order it must be considered, must be followed. For example, if I decide to select or to pick some learners, I can decide to pick some learners. I say let the first learner or the tallest learner come first, and then follows by the second tallest person, and then we have the least one. Or we say let us start from the first position, or the first person, then the second, then the third, and the fourth. That is what we call we are arranging. So that kind of activity is what we call in mathematics permutation. So in all during those old years or long ago, parents used to do what used to do to arrange their things even when they have never gone to school. They know how to arrange their things. Even up to now, you find that there are people who can arrange things when they have never gone to school. But for you to transform that activity into action or into mathematics, we say it is a permutation. So we say permutation can also be stated in, as I told you, that during those days long ago, people used to arrange their things. So you take here NB, permutation can also be stated as, look here, as learners, we have n, and then you open bracket, we have n minus 1, and then we have n minus 2, and then we have n minus 3, and so on and so forth. So dear learners, sometimes we express permutation as in this form. Remember we said arranging elements following the order, taking the order into consideration. Which order are you going to take? For the case of permutation, we are taking what we call the descending order, beginning from the highest, and then you go up to the smallest. That is the order that we are taking or considering here in permutation. So before I explain what n means, I want you to look at this. If we cannot express it in that form, we can express it in short, we say permutation. In short, we say permutation is written as n, and and then you bring this symbol here, like upside down I. So this symbol here, we call it a factorial in mathematics. Factorial. Factorial. So when you see n, then upside down I, we say it is a factorial. What does it mean? It means that can you arrange n simply means the number of arrangement that you are going to make, or the number of elements that you are going to arrange. How many elements are you going to arrange? You may arrange 3, you may arrange 10. So the n means the number. So, and then as you keep on arranging, are you seeing this? Mine into it reminds us back to what? To the previous part of quadratic that deals with the getting the factors and you multiply. So meaning that we are still under by the what? The algebraic expression, but part B, which is a binomial expression, under it we said permutation. So n simply means the number of elements. So the number keeps on reducing as you continue going descending. So you find that you begin from up, then as you take n minus 1, it means that number will reduce. And then when you take n minus 2, it keeps on reducing. N minus 3 keeps on reducing. That means that it is descending order. And then in short, we simply say Ni. Ni, it covers all this, all represent all this expansion. So Ni simply means factorial, find the factorial of that number, and it is very common with in your exams, especially the finalists, the senior fours. It is very common in both additional and basic mathematics. So let us look at how the example. How do we use this L factorial? Example 1, they will simply ask you simplify the following. Simplify the following. And then they say A, we have 4 factorial, and then we have B is 6 factorial, and then we have C. They can decide to give you in a fraction form. They can say we have 6 factorial over 4 factorial. Can say 6 factorial over 3 factorial. And then D, they will say 5 factorial over 2 times 4 factorial. So dear learners, look at that example. We said for us to write permutation, the arrangement of elements taken from a certain set, when the order is considered, it can be of this nature. And then if you don't want to expand it, because when you look at this, it is, if upon the elements are 10, then it requires a biggest space for you to use, and this may consume a lot of your time. So we shorten it by saying it is n factorial. So what does it mean? It means that can you descend the number up to where? Up to the lowest figure, and our lowest figure in countable numbers is 1. So we are going to descend the n up to the last, because when we are descending the number, we begin from the highest up to the least, which is 1. Now from this point, part A, we are going to look at the solution of part A. They said, can you simplify 4 factorial? 4 factorial. So for us to simplify 4 factorial, we simply say solution, and then you say part A. So our part A is 4 what? 4 factorial. And we have understood that 4 factorial means descend the number up to its lowest stage or term. And now for us to descend this, that means our biggest number is 4. So we begin to have 4. Look here. Here means n times n minus 1. And then n minus 1 times n minus 2. That means when we are descending, we are going to use what we call the product. We are going to use multiplication. So you say 4 by what? By the next number, which is 3. And then 3 by the next number, which is 2. And then 2 by the next number, which is 1. So learners, that is how you do what? You factorize, or you expand this. And then now after this, you are not going to stop there. You get the product of this number. So since they have told us that simplify n factorial, learners, you are not going to get the product at the end of your expansion. You only expand and you stop there. That is what the examiner wants you to do. So for those who have used short form, you can end as that as your answer. Then those who said no, I want to use expanding form, then now we shall have our expanding form. 4 factorial is the same as n into what? N minus 1. So you say this, or then n minus 2, and then n minus 3. So you move the steps depending how many elements you have. So here we have 4 elements. That means you are going also to descend to move 4 steps backwards. So 4 steps backward. Then now we come and substitute. Our n is the same as what? Is 4. So this one will be factorial. This will be 4. N is 4. And then this bracket here, we say into 4 minus what? Minus 1. And then into what? 4 minus 2. And then into 4 minus minus 1. And that is our last steps. 1, 2, 3, 4. We have moved the 4 steps. So since there are 4 elements, now from here you simplify. You don't leave it in that form. So you will have our final answer as 4 into 3, and then into what? 4 minus 2, you get 2. And then we have 4 minus, so that here is 4 minus 3 will give us 1. So you will have that as your final answer. So meaning that the 2 alternatives can all work in just simplifying a factorial number. Just simplifying the 2 steps. If you find that the first one is easier for you, you take it. If you find the second one is easier, you take it. Then you will have the same answer, because if you have to remove this, it means you have to multiply this by that. And then now we move to party B. So our party B, so party B says 6 factorial. So party B also, we say our solution, part B, is 6 factorial. So for those who say, I'm going to use what? I'm going to use the first alternative, then you will have 6 factorial is the same as move 6 up to it is lowest term. That is, you will have 6 by what? From 6 by 5, and then 5 by 4, and then by 3, and then by 2, and then by 1, which is the lowest or the smallest term. So you can stop here. Don't go ahead by getting the product or the product of that. Then those who may say that no, I want to use the second alternative, then you can say I will have 6 factorial will give me n into what? N minus 1, and then n minus 2, and then n minus 3, and then n minus 4, and then n minus 5. You count. Make sure that you count how many steps are you going to. The steps will determine the number of elements that you are doing what? That you are going to arrange. We have 1, 2, 3, 4, 5, 6. So you will stop here. And then you come and substitute. So where there is n is 6. So you say 6 into what? Into 6 minus 1. And then 6 minus 2 times 6 minus 3 times 6 minus 4 times 6 minus 5. So this will give us what? 6 into 6 minus 1, we get 5. So we shall have 6 by 5, and then we have 6 minus 2, we get 4. And then we have 6 minus 3, we get 3. And then we have 6 minus 4, we get 2. And then 6 minus 5, we get 1. So, dear learners, this is what you are to do when you are asked to do what? To simplify any factorial number. And then now we move to part C. So dear learners, take note of this, that when you are going to make a factorization or to factorize or to permutate the any element, you make sure that you choose one alternative. If we are taking the first one, then you go with that one. If you find that the second one is the best for you, then you go with this, but don't use both, because in your answer or your solution, if you say, oh, we cross all the answers. We cross all the answers. So you only take one because all of them serve the same purpose. And then now we move to part C. So part C is part C. Part C, it says it is 6 factorial over what? Over 3 factorial. So 6 factorial over 3 factorial is going to be challenging to some of you, but what you do, you will simply have this. Now if it is like this, then you are going to expand. As long as you have seen this part there, that is a factorial, you have seen that part, that symbol or that sign, it means that can you arrange your number or your element from the biggest up to the smallest. So we are going to arrange first the numerator, because 6 factorial is not 3 factorial. So this person can arrange his 6 element, and he can also arrange his 3 element separately. So we shall have here 6 by what? By 5, and then by 4, and then by 3, and then by 2, and then by 1. These are 6 steps that that person has moved. And then when we come to part the denominator, so the denominator we are going to move 3 steps. So you say over 3 steps. So how do you move the 3 steps? You can begin from ascending, or you go by descending. It will all still give you the same answer. 2 and then 1. Then now you find that for us to eliminate the division, we are going to cancel 1 with this 1, 2 with this 2, 3 with this 3, and then we remain with only 6 by what? 6 by 5, and then by 4. So 6 by 5, and then by 4. Sometimes if you feel like you want to get the final answer, you can still, if it is division, you can multiply this. This is by this 30. 30 times 4 will give us 120. So on the final answer, you will get here 120 as you whatever, because of the division part. Then number D was 5 factorial divided by 2 times 4 factorial. 4 factorial. So learners, look at this part. Here we are going to do what? We are going to move the numerator because it contains a factorial. So you will have 5 by what? By 4, and then by 3, and then by 2, and then by 1. Then divide it by 2 does not contain any sign of a factorial. Therefore, you only take 2 as a whole number. Then multiply it by 4 factorial. Means 4 by 3, by 2, and then by 1. And then here you can eliminate 1 by 1, 2 and 2, 3 with 3, 4 with 4. And then now you remain with what? You remain with 5 divided by 2. So 5 divided by 2 will give you a simple answer as 2 point what? 2 whole number, and then 1 out of 2, which is 2.5. So that is how you simply deal with that. If it is not containing a factorial, you don't take any step. So dear learners, with this introduction, or with these examples, I believe that you have at least picked something on how to deal with permutation. And I conclude by saying that permutation is arrangement that is involves of element, or taking element from a given set, but the order must be considered, and the order here is descending order. And then if we are asked to write permutation in short, it is I factorial. So I factorial means you move that number from the biggest, from where that number is, up to the last term. With these learners, we have come to the end of our lesson for now. And I just have 2 questions for you to take it as your exercise. Only 2. Only 2. Take this as, you say, your exercise. I want you to try this. Simplify A 7 factorial over 5 factorial. B, we have 9 factorial. 9 factorial. And then lastly C, we have 5 factorial 2. 5 times 2, 5 factorial times 2 over 3 factorial. So, dear learners, with that we have come to the end of our lesson, and I wish you the best. Thank you so much.